Welcome to Artificiality, brought to you by the founders of Sonder Studio. Artificiality is a podcast dedicated to understanding the emerging community that is humans and machines. We take the latest in the human side, decision science, psychology, and design, and put it together with advances in artificial intelligence and big data so that you can understand how to work better with machines and your fellow humans. We founded Sonder Studio to help people be more human in the age of AI. We're on this learning journey too, so we strive to find the frontiers, to ask the best questions, and stay curious. We interview some of the top minds working at the intersection of humans and machines and make sure we have a few laughs along the way. On a scale of 1 to 10, rate how well you understand how a toilet works. Now, take a moment to explain how it works. Now, after you've tried to explain it, does your rating of how well you understand change? If you're like most people, the act of trying to explain will highlight that you don't understand it as well as you thought you did. This is called the knowledge illusion, and it's where we feel we know more than we do because we get our knowledge from our community, both human and machines. So what's so interesting about this illusion is that it says so much about how we should approach others, and it also says a lot about how we should approach having our knowledge inside of machines. We talked with Steven Sloman, professor of cognitive, linguistic, and psychological sciences at Brown University, who, along with Philip Fernbach, popularized this idea in a book called The Knowledge Illusion. How does a conscious recognition of our knowledge being derived from our community affect our experience in the world? Steve, thank you so much for joining us. We're happy to have you on the Artificiality podcast. I guess maybe to start off with is more of a sort of a general question is, can you help us understand the human meaning of the knowledge illusion? What does this mean to us as humans in our experience of the world?
Well, I think what it means more than anything is not about our experience so much as what we should be incentivized to do with regard to other people, right? So the knowledge illusion is the fact that people tend to think they understand how things work better than they do. And so, there's lots of good reasons for this. I mean, it gives us a confidence when we're building things, when we're talking about things, when we're trying to understand how the world works in order to make predictions and generate explanations and feed ourselves. And so really, I think where it comes from is our tendency to fail to distinguish what others know from what we know, right? So the cause of the knowledge illusion, I believe, is that we tend to assimilate knowledge that's sitting in other people's heads. And in that sense, we really live in a community of knowledge. It's the community that determines what we know. And so there are obviously good reasons for that. But what that means is that the implication of the knowledge illusion has to do with how we relate to other people for the most part. I mean, not exclusively, in the sense that the knowledge illusion will affect us if, we think we can fix our own toilet and it turns out that we don't understand our toilet as well as we thought we did, right? So we're going to end up calling the plumber, but unfortunately only after we make a mess. So in that sense, there's an implication. But because it has to do with our relationships with other people, I think the major implication has to do with being more humble, understanding the limits of our own knowledge, especially when we're communicating with others.
That was definitely my personal experience, I have to say.
Very much so.
Well, and you're just so conscious of asking questions of other people as well and listening. You listen differently. I think you listen to their explanation. You watch their faces to see how much they're thinking. And it makes me, when we get into some of the deeper AI questions, it certainly made me start thinking a lot more about how we query the machines.
Well, you talk about the fact that there's something different that happens when you're forced to explain something. Mm-hmm. So we've adopted your thought process around and your question about whether we understand how a toilet works. Mm-hmm. And we actually ask people, how well do you know how a toilet works? And then they have to explain it. Yeah. And then they rate again, how well they explain it.
And do you replicate our findings?
Yes, every single time.
No, one time.
Well, one person actually did turn around and say they understood it better, which we're still trying to understand. But the vast majority, right, follows the findings. But why is that? What's going on for us that we have that pattern?
So I think there are two different ways to think about it, and they're probably both right. It's probably overdetermined in that sense. So one way to think about it is that we have an intuitive understanding. Like this intuitive understanding comes from all the experience we have with toilets, and we have lots of experience, right? So we know that there's a lever you push, and we know that usually, but not always, the water goes down when you push that lever. And, we know how to use it. Sometimes you stand, and sometimes you sit, and sometimes you raise the lid, and sometimes you don't. So we're very comfortable with it at an intuitive level. And that intuition sort of overcomes our field and causes us to think that we have a more deliberative type account, right? So explanation is sort of the task we do that is the best example of deliberating, right, as opposed to intuiting. When we have to generate an explanation, we really have to bring all the structure to mind. We have to really understand things in a very explicit way so that we can articulate them. And I think we surprise ourselves that things that we interact with successfully intuitively, we actually don't interact with so successfully deliberatively. We can't generate those explanations. So I think that's one way to think about it. Another way to think about it is that in certain domains, like any domain that involves other people, we tend to think in terms of fundamental principle, right? Like we'll often take, say, a moral perspective and think that, we should vote a certain way, or we should support a certain candidate, or have a certain attitude about AI because our basic, fundamental, sacred, or protected values warrant that particular position. And then when you ask someone to explain, what you're generally doing is asking them to take a totally different framing of the issue and think about it causally rather than in moral terms. And suddenly they realize, things aren't quite as simple as I thought. Because, moral conversation tends to oversimplify, and causal conversation tends to force you to appreciate the complexity of things.
In that vein, if you're reasoning backwards from an effect to a cause, and that's more difficult to do, but as you say in the book, you're more able to spot errors. Is that part of what's happening, that people are able to spot the errors in their reasoning when they're almost going from a moral to a causation is like kind of stepping back in that same sort of way?
Interesting. Well, I've never thought about it in terms of a moral framing to a causal framing, but I certainly think you're right that diagnostic reasoning requires deliberation. There are some famous psychologists, a guy named Keith Holyoke and his collaborators, who have argued that humans are the only animal capable of diagnostic reasoning. Because it really does require a special facility, right? The facility to see something and generate an explanation for what produced that thing. So we're sort of going back in time when we reason diagnostically. That certainly requires deliberation, right? Intuition is generally insufficient. I mean, if we've explained it many times before, then that explanation will come to us intuitively. right? If it's very well learned, anything that's well learned will be intuitive. But the first time we do it, then we have to think, we have to generate a model, we have to think about the model. And that may well be why, in a certain sense, we make fewer errors when we're reasoning diagnostically as opposed to reasoning forward in time or predictively or causally, because we have to think more carefully because it's so unnatural.
It's an interesting thought when you compare that to like the way that a machine learns, or the paradox of learning for humans, that the more we know about something, the less open we are to new information. So it's this constant challenge to stay open to new information, especially when it's foreign. And I do like the way that you point out in the book that deliberation is inside our own minds as well as with others. Makes it such a useful term.
It's a beautiful term in exactly that sense, right? Like we deliberate inside our own skulls when we're thinking about things, but the word in English also means talking to other people. It's almost a synonym of conversation in certain contexts, right? Like a jury deliberates, and so it has that social aspect. And I've definitely come to believe, and this actually is kind of new to me. I've only come to this belief by virtue of thinking about and writing the book, that a lot of our deliberation, if not most of it, really involves other people. I mean, there are substitutes for other people, like machines, and, paper kind of serves as another person. It's a way for us to get outside ourselves and respond to ourselves when we write things down or draw things on boards. But I definitely think deliberation involves a kind of dichotomy. At minimum, it involves a dichotomy within ourselves so that we're speaking to ourselves if there's nobody else to speak to.
What happens when you deliberate with someone who has knowledge that's beyond your current comprehension, or maybe beyond ever? You can think of, I'll talk to somebody about quantum physics or Bayesian algorithms, which consistently put my head into a spiral. So I can deliberate and try to learn from them, but it's just beyond my brain's ability to really, understand. Am I accepting their knowledge as part of the illusion because I can't quite hold my own? I'm not sure how to think about that.
Interesting. Yeah. I don't think there's a simple answer to that. So there's this effect called comparative ignorance, which in a sense is the opposite of the knowledge illusion. If you're beside an expert and you're asked to answer a question that's in the expert's domain of expertise, then you actually become less certain and less confident in your response because you're comparing your response to the experts, right? On the other hand, if you walk into a classroom and an expert is holding forth in a very clear way about a subject matter, then, I think the reason we're often captivated by that experience is because we feel so knowledgeable, right? Like we're participating in this spouting of knowledge, and as long as we understand what the expert is saying, then we feel very knowledgeable. If the expert's getting up there and saying something incomprehensible, then we don't have that feeling, right? We just sort of feel stupid and annoyed. But if we have that momentary sense of understanding, then I think we have a habit of sort of blowing it up so that we really understand in a way that we don't, as we discover when, we go home and someone asks us what the lecture was about and we flail around trying to explain it.
I've definitely had that experience. Does that extend there to an interaction with a machine? So we know that, a machine, an AI system, can see across essentially infinite dimensions, right? We as humans have a limit to the number of dimensions that we can see in data. Machines can see patterns in data that we can't even comprehend because we can't figure out how it's weaving its way through this data. We call it yoga AI. And we also know that there is a unit of evidence inside data, big data, that is basically unreadable by us because it's only readable by a machine. So when a machine comes to us and gives us a prediction and says, this is what's going to happen next week, are we having that same sort of reaction that this is an expert? And so therefore I'm kind of in awe of the expert. I'm in awe of my professor, and I'm listening to my professor speak. I'm just like, oh, this is incredible. I may not be able to tell my friend about this, but I believe it.
Mm-hmm. Well, the data, unfortunately, are a little equivocal in that question. I mean, it depends on a lot of things. So if you believe that the machine is an expert, then I think, yes, you do have that experience. So Adrian Ward has done studies, and Matt Fisher and Frank Kyle have done studies showing that when you ask people general knowledge questions and give them access to Google to answer those questions, then later, when you say to them, I'm going to give you another general knowledge test, you won't have access to Google. How well do you think you're going to do? People think they're going to do better if they've just experienced Google, right? In other words, their experience of being able to answer questions, even though it was actually the machine that was answering the questions, gives them this sense of confidence, understanding, and in fact, it increases their self-esteem, is what Adrian Ward shows. So in some sense, I do think, there is a knowledge illusion with machines. But I think more generally, the answer is going to depend on where you think this answer is coming from. So do you trust the machine? Have you had good experiences versus bad experiences with it in the past? Right? Like Google answering general knowledge questions is a very special case. I don't feel that way about Google giving me directions on Google Maps, for instance, right? Because it makes lots of mistakes, and it does things that drive me nuts frequently. So a lot of it has to do with your experience. But the thing about modern AI is that unlike human beings, it rarely justifies itself. So it can deliver up a Wikipedia page, which you can then read and maybe understand where its prediction is coming from. But that's not sort of the source of its prediction, right? So if it's if Google Maps is telling me to go right, it doesn't normally tell me why it's telling me to go right in a way that I can understand. And in fact, as you know, often it doesn't understand why it's telling me to go right, right? That's the nature of modern AI algorithms, or some of them. So I think a lot of it has to do with your experience with the machine, and also the degree to which the machine gives you a picture that you feel comfortable with that serves as a kind of explanation for why it's giving you the advice that it's giving you.
Yes, we spend a lot of time thinking about how to create a good explanation when we're working with other people. And we sort of spend quite a bit cognitively, it seems, to explain ourselves if someone asks us. But our expectations about what we would see in a machine explanation don't necessarily seem to get driven by that same pattern. So you mentioned trust before in your previous experience of trusting the machine. Does what you've thought about in the knowledge illusion and how we apply it and how we think about it with machines, does it make a more complex picture around automation bias, for example, and how we should think about building trust with machines and the limits of that trust? We don't And there's so many examples of people even driving into lakes following Google Maps when the lake is clearly in front of them, but they still follow the directions of the navigation system. Mm-hmm. And that, of course, would be catastrophic with medicine if it was an obvious error and a human made a decision to just parrot it. But almost the way you described what you described in those two different sort of dueling ways of thinking about knowledge was that there's an experience of feeling like you're either in or you're out. If you walk into that lecture and you're just completely overwhelmed by it, you know you're totally out. But if you walk into the lecture and you understand it and you get that initial hit of, wow, confidence, self-esteem, maybe there's a different way of thinking about automation bias based on the level of confidence and self-esteem it gives someone, not necessarily the level of trust that comes as a result.
Trust itself is a complicated concept, right? There are many components to trust. I mean, one is thinking the agent, person or machine, shares your interests, but another is thinking that it has a kind of loyalty, and the really important dimension is thinking that it's competent, right? So, I mean, you're absolutely right that, the issue is complicated, but I think trust itself is complicated. I will say I'm not entirely convinced that machines and humans are really different in this regard. That is, you're right that people like to explain themselves, but often those explanations have very little to do with why they believe what they do. Right? Try to get someone to tell you why they like vanilla ice cream over chocolate. I mean, people will say things and they'll talk about their childhood or what they're reminded of, but who knows what it has to do with why they act. I mean, it's just not something we have knowledge about, right? Or why we think a particular painting is beautiful.
But we trust their explanations, even if it doesn't make sense, even to them, even if they don't know why. We trust that if you said, "I love vanilla ice cream over chocolate," I'd say, "Okay, great, I believe you."
No, you'd believe my preference, but if I told you why, would you believe my explanation?
I don't know. I guess it would depend on what the explanation is.
Exactly.
And I don't know enough about taste or preference to maybe question it. Maybe there is something biological that I don't understand. But if you said, "Oh, I just love it because it reminds me of my grandmother," that to me would make sense. I'd go, "Oh, okay, that makes sense. He's got he's remembering something." But I could see what you're saying is that sometimes we don't know, and we're not going to understand the explanation.
Human beings have this tendency to accept what they're told, right? Like, this is actually one of the striking things about people. And I think one reason we're so susceptible to fake news and to being influenced by the people around us, because we tend, for the most part, not to be critical, right? There are obvious exceptions, but there's a lot of data suggesting that certainly when people are not like in a classroom or having an argument with someone or have a competing interest and someone says something, if someone comes up to you and says it's raining outside, then you'll believe it's raining outside, usually, right? Mm-hmm. And so I think you're right about explanations. We do tend to take them at face value. But that doesn't mean that there's not a distinction between the actual source of a belief and what people say about it. And this becomes very clear when you're talking, when you're having a conversation about a moral issue or about a political issue.
I'm really interested in this idea of storing our information in the world and outsourcing our thinking. The sort of those two kind of dimensions, particularly when it comes to thinking about AI, really advanced AI, and heading towards things that are more general, not just like a recommendation algorithm on Amazon or something, but much, much more broad applications of AI where how do we think about developing AI that can, if so much of what we experience and our learning is so embedded in the physical world and in our bodies. That's a fascinating sort of thread, I think, to pull on. Can you talk a little bit more about how you've evolved your own thinking about that?
The fact that our thinking tends to be so much more superficial than we think it is has, as I said, suggested to me that we depend on others for our knowledge, and we fail to distinguish what we know from what others know. But I don't think we only depend on other people. We depend on our bodies and the world more generally, right? So kids use their fingers to count, and mathematicians use blackboards to do math. Many of them just can't do math without it. So we use things outside our brains all the time in order to think. In cognitive science, this is called embodiment, right? The embodiment perspective on cognitive science, and there's tons of evidence for this. For instance, if you ask people to think about a hammer, then it turns out, the part of their brain that's associated with grasping lights up. So machines are kind of the ultimate contributor to this, community of knowledge writ large that includes the world and physical things and our bodies. They just have become a storehouse par excellence of everything we want to know. And, it worries me in the sense that if we ever reached a point where, we could no longer produce electricity, we would lose all of our knowledge, right? We would just not have access to it. And I don't think that we could really recover from that. Joe Henrich has written a great book that includes stories about how, certain cultures, when there was disease that ravaged the older population, just lost their cultural knowledge, right? They could no longer make kayaks to go fishing because that knowledge was stored in the elderly people of the culture. And so we use machines more and more for that.
I love that one of the examples you have in that chapter on embodiment, I love, which is the one about how we judge where a baseball is going to land if we're going to try and catch it.
Yeah.
And I really enjoyed reading it. I'm not a baseball player, and I can kind of catch a ball, but I totally understood the experience of being able to back up and kind of figure out where the ball is.
Yeah.
I never could have explained it. I have absolutely, until I read it in the book, I had absolutely no idea what calculation was happening and the angle of the ball and how I was keeping that and moving the velocity. You do a wonderful job of actually making it quite simple to understand, even if I can't recall it.
Yeah.
But I can see
it wasn't trivial to write it.
I'm sure. That's why I intended that as a compliment. Yeah. But I can see how that gets translated when you think of using a machine like a calculator. I can put in lots and lots of numbers and multiply lots and lots of numbers and press equal, and the calculator is giving me an answer, and I've outsourced that. And I don't know what that multiplication is, but I trust that answer.
Yeah.
It gets to be more complex, and I'm not sure how to think about it when we move towards machines that are making predictions that are based on probabilities where there is obviously and always an error rate.
Yeah.
Right. So the baseball is based on gravity, right? And other laws of physics that don't change. The calculator is based on, computational math that doesn't change. A prediction of what, sales are going to be next year based on some sort of probabilistic function, there's an error rate, but we're trusting that machine perhaps as much as we're trusting the other things.
Yeah. And surprisingly, we are. I mean, I've been doing some research recently looking at whether we trust humans or machines more for instance, for decisions about hiring people in a company. And our data indicate there's really not that much difference in people's willingness to follow the advice of a machine over a human being. So we do trust in that sense of being willing to take advice. And you're right, that most of the decisions we make are in uncertain domains where we just can't know for sure. That's true with people too, though, right? So when you say to your doctor, how should I treat this rash? Often the doctor will say, get this cream, right? Buy this pill, ingest it, take it, and we'll just do it. Or at least in the old days, that's how it was. I think patients are taking a little more control now. So I think what you're describing is an interaction between advisors and advisees. That is true whether the advisor and advisee are humans or machines or one of each. One potential advantage. So you're right that sometimes we treat the advice of a machine as being more certain. We treat machines as being more infallible than they are. Again, I think we do the same thing with human beings. One potential advantage of a well-designed machine is that it can tell you how certain it is. And the algorithm can be forced to report that. So imagine if, instead of giving you the forecast that this stock is going to be worth $83.72 in 2 years' time, it said it's going to be worth somewhere between $40 and $120 with probability 0.95, right? Which is probably the kind of confidence range that is more realistic in general. That's how all advisors should be giving advice.
What happens when you ask people to do that? When you ask people to do that as opposed to machines, you say, I think it's going to be, 84, and I'm 30% confident of that. What happens to that to that relationship with the other people? Like, is it the same for the machine as it is for the human in that sense?
So in that domain, people are notoriously overconfident, and their confidence ranges are notoriously narrow, right? So people will know that they can't guarantee 84, 73, but they'll say something like between 70 and 90 instead of between 40 and 120, right? So they'll give too narrow a range. And if they were honest, or not if they were honest, because they are honest. They actually believe that much certainty is reasonable. But if someone was given the true range, the problem is that it's generally so wide that they wouldn't know what to do.
Well, that makes sense. I mean, there was I think, is it Kahneman who says that overconfidence is the mother of all biases, and that if you took it away, you'd have to completely deconstruct our brains. That's not quite this quote, but it's something like that. It's so embedded in our thinking. And so you think, okay, well, let's try and get people to be less overconfident. But then what you're saying is the real problem is two-pronged. It's not just the overconfidence. It's the fact that once we have a wide range, we don't know what to do with the wide range. We're constantly trying to pull things back into certainty, even if it means false certainty.
Yeah. I mean, we always in the end can only do one thing, right? I mean, we can only treat our disease in one way, or one at a time anyway. Or, those of us who try to be good will only order one menu item and not multiple menu items at the restaurant. And so in the end, we have to hone it down to one choice. And we really appreciate when we're given advice that allows us to do that quickly, thoughtlessly, automatically, right? Barry Schwartz has this beautiful book. It's several years old now, called The Paradox of Choice, which is about, the pain associated with choosing, and how in the West we tend to be given more choice than is good for us. And it leads to a lot of problems. So there's a sense in which, we don't want to spend all our time making decisions. And if the doctor says do this, then that's a decision that I no longer have to make.
I'm struck by another example that you talk about, the experiment with where people were asked to read text on a screen, and the computer tricked them by making the words they were looking at legible, but everything else around it was a mess.
Right.
But what was so fascinating to me about that was the fact that the people didn't notice that everything else around it was illegible.
Right.
But what was most important to me about that was the fact that they thought that everything else around it was meaningful because the one thing they were looking at was meaningful. And that stuck with me in my head because I keep thinking of the number of times that someone will be presented with a slide or a dashboard with one bar chart about what's happening in a business or whatever the context is. And how much are we assuming that everything around that one thing is meaningful too, even if we can't see it?
Right.
You know, it's a huge amount of data stuck in some data lake that we can't understand. But the one thing that's been extracted and we're looking at makes sense.
Right.
So everything must make sense, right?
Right. Oh, yeah. I mean, we are pattern completers, right? That's what the brain does, I think. And in fact, that's what deep learning machines do too, right? So, I mean, these recent developments in modern AI they shock me because they actually strike me as incredibly plausible, analogs for what it's like to be human. But I think one difference between us and machines is, so the experiment you're talking about, let me describe it very quickly for those viewers who haven't read the book. But rather than describe what I report in the book, I'll describe my first encounter with these things. So I was at a conference, and there was a setup where someone had an eye tracker on, and they were looking at this painting, some beautiful impressionist painting. And behind them, I could see that, in fact, what they were looking at was white noise, except for this little window that moved around the painting and revealed what was in that portion of the painting. But the machine was designed so that it was tracking their eyes, so what they saw was the part that made sense, that wasn't white noise. And that person had absolutely no idea that the rest was white noise. They thought they were just looking at a painting, right? As if they were in a gallery. And what this suggests is that we believe that there's this three-dimensional world around us and that we have a kind of model of it inside our heads, right? So, if you close your eyes now and ask the question, what's behind you or what's above you, people are surprisingly bad at answering that question, or close your eyes and what color are your socks? People are surprisingly bad at answering those questions. And they're surprised because they think they're living in this three-dimensional world and they have a model of it. They know where they are. They're oriented. It turns out they don't really. It turns out we're looking at the world through blinders, and what we're aware of is what we're looking at. So, I think modern deep learning machines are really good at completing patterns and at taking little bits of structure and completing the whole scene, which is what humans are good at too. The difference is I have no reason to believe that deep learning machines have this underlying belief that they have a three-dimensional model of the world.
Does this mean that our perception is somehow predictive as well as just taking data from the world, that we're actually predicting things as we're matching what the data that comes in with the model that we have in ahead of our conscious awareness? Or how does that play in how we perceive the world?
Well, so let me say three things about that. So first of all, what I just tried to argue is that we don't actually have a model. We just think we do. right? So in a sense, the question doesn't really follow. But it is the case that there are some very prominent theories of how brains learn, which are based on prediction, right? Prediction success and prediction failure. And the basic idea is that, we're constantly making predictions, and when we make mistakes, that error gets fed back such that, we change synaptic connections a little bit in order to reduce the error, right? So we are reducing prediction error continuously on these models. And they're actually pretty successful models in many domains. But it's also interesting that there are cases where we don't seem to be making predictions, even though it seems like we should be. So often we're surprised, right? And you would think, well, surprise is a function of a prediction failure, right? We expected something and it didn't happen, so we're surprised. Well, it turns out that can't be true because, if you're in your backyard and a squirrel comes along, you didn't predict that squirrel, but you're not surprised, right? Because, well, at least where I live, there are squirrels all the time. So it's not mere prediction that's determining whether we're surprised, right? Now, if the squirrel came along and it had no fur, then I'd be surprised, right? Or if it were like dragging a badminton racket in its mouth or something, then I'd be surprised. So there's some reason to think that what determines surprise isn't a failed prediction, but an observation that contrasts after the fact with what we would have expected, right? So we're kind of post-dicting constantly in order to determine surprise.
It is fascinating to us over the last several years of studying AI and is watching how much we're learning about ourselves as humans in parallel. I don't know enough to know whether it's causal, but there's something that's happening that seems to be we're uncovering so much more about our own human knowledge and our own human perceptions and how we relate to each other at the same time as we're doing this work of trying to figure out how to work with machines. Do you think that those two are connected, or are those just correlated? And I'm making an assumption that we're learning from that.
So I'd actually really enjoy interrogating you on that. So, like, what it is that you think we've learned about people from AI. Unfortunately, I think it would take more time than we have right now. What I definitely think is that whenever there's an advance in AI, people think it's an advance in cognitive science as well, right? So every time a computer engineer develops some fancy widget, somebody, usually that very engineer, asks the question, I wonder if people work this way. People must work this way. After all, this is doing something amazing, and people do amazing things. So I guess I've uncovered something about how people work. And as I said, I actually think in the case of deep learning, that's true. Like I've been shocked by what these machines can. There are definite limitations, and I'm sure you know those limitations as well as I do. But the notion that we're pattern completers, that we have vast storehouses of memory that allow us to make sense of things really rapidly, just makes a lot of sense. There are other things, like old AI used to be people building fancy computer programs in, whatever computer language they had available. And I'm not sure that in the end those turned out to have much to do with how people think. or expert systems that used to generate probabilities and multiple diagnoses. I mean, no, I'm not sure that really is how people think. So I think there are some examples that conform to what you're saying, but I actually think that AI has been overrated as a source of ideas in cognitive science, and sometimes has actually led us astray.
It could be a good example of my confirmation bias, that since I've been learning a lot more about cognitive science at the same time as I'm learning about artificial intelligence, that I'm conflating the two in my brain.
Yeah, well, I think it's also, it makes you more curious, I think. So when we work with people, teaching them about things to do with AI, one of the things they do is try and complete the pattern to their own thinking.
Sure.
So, you kind of run through, this is how Bayesian network works, and update prior probabilities, and people think, oh, maybe I update prior.
Well, and also you think about what we talk about is that the new most valuable raw material is human behavior, right? As companies try to use our human behavior to get us to buy things or to click on things or whatever else, that study of human behavior has become so fundamental, and it is quite new in the computing world.
Right.
Before that, it was Don Norman's designing things with the affordances to allow people to be able to make devices that they could use, right? That was sort of the Silicon Valley interest in human behavior.
Right.
Now it's much more ingrained to try and figure out how to encourage people to do things and make choices.
Interesting. Yeah. BaseNets are actually a very nice example, I think, of the divergence between AI and cognitive science. I mean, I got very excited at one point about causal BaseNets, right? Judea Pearl and other people's ideas about how we could think about causal understanding of the world in terms of interventions over probabilistic engines. And I'm still excited about the ideas in some sense, but it's very clear to me that the way people deal with causal systems is very different than the way these causal BaseNets deal with causal systems.
Yeah, and that was one of the questions we were interested in exploring, actually, even if we come right up to time. The idea that, a few years ago, it was like causation's out, correlation is all that matters, right? And that just seemed to me at the time to be just completely absurd. Like, what a dumb idea. Everyone wants to know the reason for something. We believe there's a reason. We want to know the reason.
Right.
Where do you sit on that? How do you think about the difference between, like, I want a correlative answer, I care about correlation, versus I still want this answer?
Yeah. Well, I think about it in terms of generalization, right? So if you have, so these deep learning systems are correlational, right? Like they're incredibly highly dimensional correlation machines. And they can do an incredible amount of work, an incredible amount. And they generalize very well, but only to similar things, not to dissimilar things. And, you can break these systems by presenting something that, say, is consistent with the correlational structure, but not consistent with the world, right? Like, that's how you create an image that the machine will think is a penguin, even though it looks like, a Mack truck to you. So I think causality remains really important and is not at all captured by these systems, because it's our causal understanding that allows us real flexibility. It allows us to enter entirely different situations and make sense of them, right? It's what allows us to, sit in a totally new vehicle that we've never sat in before, that might not even have a steering wheel, but instead levers or something to turn wheels. And, we'll get it and we'll figure it out very quickly. Whereas a deep learning machine would just not be capable of that, because you can't generalize on the basis of similarity. So, I think the right way to think both about people and about successful AI is that there are two different kinds of computation that have to go on. One we can think of roughly in terms of correlation, and another, I think, has to represent causal structure and spatial knowledge and, certain other kinds of things that support real explanations.
And help us make sense of things.
And help us make sense of things and not just predict, right?
Yeah. Well, thank you very much for your time. You've been very generous with us and given us plenty more things to go off and try and learn. And try to be better questioners of ourselves. I've found a couple of things already in this 1 hour that I've been mistaken about. So it's always good to learn and know something new.
Well, thanks so much for having me. This has been really interesting, and I've learned a lot too.
Now, before you go, during our recording, we forgot to ask Steve our final question. We followed up an email. We asked him, if you were going to give the designers of AI 2 pieces of advice about the core tenets of AI design that will work best for humans, what would they be? Here's what he replied. Number 1, the AI should have sufficient intellectual humility. When making predictions or giving advice, it should be honest about its degree of certainty. Often this will require admitting that it doesn't really know. When providing information, it should come up with a credible estimate of the likelihood the information is correct and complete. This is important as a means of reminding users of their own ignorance and of calibrating their confidence. Number 2, AI is not nearly as good as humans at understanding human intentionality and at sharing intentionality with humans. Most AI could make more effort to understand what humans are trying to do and how the machine can help before offering advice or information. AI needs to understand its own limitations so it can try to fill the gap before making its contribution. Thanks again to Steve for joining us on the podcast. It's better than solid state.